We're going to talk about molarity, not two of the Three Stooges. Molarity is a term we use in chemistry to discuss concentration of solutions. Okay? So first we want to understand that a solution generally has two parts. We have what's called the solute. The solute is the part of the solution that dissolves. Most of the solutions we're going to be working with are aqueous, and in an aqueous solution, the solute is the stuff that's dissolved in the water. Sodium chloride or some usually ionic compound or some soluble molecular compounds. Okay? The other part is called the solvent, and that's the part that does the dissolving. In the case of an aqueous solution, the solvent is water. Okay? So solute, solvent. And when we talk about concentration or molarity, what we mean is the ratio. And it's a specific ratio. You notice in the word molarity, you hear the word moles, right? Or mole. Molarity is the ratio of moles of solute, how many moles of solute you have dissolved, over the total volume of solution, okay, in liters. The units of molarity are moles per liter then. Or we sometimes just use a capital M and it's usually underlined. That capital M you've seen before. For example, 6M HCl, the M is molar. That means there are 6 moles of HCl per liter of solution. Okay? So molarity is the number of moles of solute divided by the number of liters of solution. Here's an example. We're going to make a solution. We're going to dissolve 15.00 grams of sodium chloride into 750 milliliters of water, and we want to calculate the molarity of that solution. Okay? So remember, molarity is moles of solute over liters of solution. Okay? So the first thing we need to do is to figure out how many moles of solute we have. Well, sodium chloride, NaCl, is the solute. So to find the number of moles of solute, we take 15 grams and we multiply by 1 mole of sodium chloride over its molar mass, 58.44 grams, and we get 0.2567 moles of sodium chloride. That's moles of solute. That's the top part of my fraction. Okay? 750.0 milliliters is the volume of my solution. Now, the nice thing about molarity is, for the most part, we don't have to worry about changing the volume of water when we add a solute. Solutes dissolve into tiny, tiny little particles that actually fit into the spaces between water molecules, and so you're not going to alter your volume of water by adding a solute to it. Now, if you add a whole lot, you might change it a little bit, but we're not going to really be working with solutions like that. Okay? But molarity has to be calculated with liters of solution. So 750 milliliters is equal to 0.7500 liters. Notice I keep all of the significant figures when I make that conversion. Just move the decimal point 3 places to the left. Okay? So molarity is the number of moles of solute, 0.2567, divided by the number of liters of solution, 0.7500. 4 sig figs in each of those, so my answer should have 4 sig figs, 0.3423 moles per liter, or just 0.3423 m. That's how you calculate molarity. It's very simple. Now we can use molarity as a conversion to find, for example, how many moles of solute are involved in a certain amount of solution, or how many grams of solute are in that particular volume of solution. Okay? There's 2 sort of magic formulas that I call them. The first is liters times moles over liters equals moles of solute. So liters is the volume. Moles over liters is the molarity. So volume times molarity is equal to moles of solute, because liters will cancel. You'll just be left with moles. The other one is, if I want the mass of solute, it's going to be volume, liters, times molarity, moles over liters, times molar mass of the solute, grams over moles. And so you'll see liters will cancel and moles will cancel, and I'll be left with grams of solute. So these are 2 very, very useful versions of the same formula that we use all the time. Volume times molarity gives you the moles of solute. Volume times molarity times molar mass gives you the mass of solute. Remember them. We're going to use them a lot. Here's an example. What mass of potassium hydroxide is needed if I want to make 255.0 milliliters of a 0.125 molar solution? So let's say I'm doing a calculation, or I'm doing an experiment, and the experiment calls for 255 milliliters of potassium hydroxide whose concentration is 0.125. I need to make this solution. I don't just have a bottle of this hanging around. I do have a bottle of solid potassium hydroxide, and I have water at my disposal, so I'm going to make this solution. I'm going to measure out 255.0 milliliters of water, and now I need to know how much potassium hydroxide do I have to dissolve in there to get a solution whose concentration is 0.125 molar? So I'm looking for the mass of solute. All right, mass of solute is volume times molarity times molar mass. The volume was 255.0 milliliters, so I have to convert that to liters, 0.2550 liters. The concentration I'm trying to make is 0.125 moles per liter. And the mass of potassium hydroxide is 56.11 grams per mole. That's the molar mass. Liters cancel, moles cancel. I'm left with grams. I have 4 significant figures in my volume. That's the one that's the one that I'm going to use for sig figs. So 1.789 grams of KOH is needed. So I go and measure out 1.789 grams, and I dissolve it into my 255 milliliters of water, and I now have a solution that is 0.125 molar. So sometimes you want to make a solution of a particular concentration, but you don't necessarily want to make the solution from scratch. In other words, you don't want to measure out the mass of solute and dissolve it into water, because sometimes dissolving the compound takes a little while. There's an easier and faster way to do it if you have some stuff that you need, and that's to make a dilution. Okay, so you can, for example, take a very concentrated solution. We sometimes call those stock solutions. And you can make it less concentrated by adding more solvent. You add more water, and it makes it less concentrated. It dilutes it. Okay, so stock solutions are called stock solutions because they're kept in a stock room, and they're used to make solutions with lower concentrations. You can't go the other way. You can't take a concentration that's smaller and make it into more concentrated, well, without actually evaporating off some of the water, but it's really hard to get that accurate. It's actually very easy to go from concentrated to less concentrated by making a dilution. See, the idea behind this is if you have a certain solution of concentration and you add more water to it, you're increasing the volume of the solution, the denominator of your molarity calculation, but you're not increasing the moles of solute by adding water. You're just adding water. So you're not increasing the mass of the moles of solute, which is the top of that fraction. So the overall value of the fraction will go down. Molarity decreases if you decrease the denominator without decreasing the numerator. Okay? The formula that we use is M1 times V1 equals M2 times V2, where M1 and V1 are the concentration and volume of the concentrated or stock solution, and M2 and V2 are the concentration and volume of the dilute solution. There are 4 variables in this equation. You have to know the values of 3 of them to use it. So oftentimes you'll know M2 and V2 because you'll know what you're trying to make and how much of it, and you'll know maybe the concentration of your unknown, your stock solution, but you won't know how much to use. And so you'd be solving for V1 in that case, okay? Here's an example doing just that. So I have full strength hydrochloric acid, 12 molar HCl, and I want to make 550 milliliters of HCl that is 1.050 molar solution, much less concentrated. Why would we want to do that? Well, the lower the concentration, the more controlled a reaction is. So I might want to control this reaction and not have it just go really, really fast and maybe get a bunch of impurities in there. I also don't generally want to make more solution than I need because this stuff isn't free. You have to buy it, so we don't want to use too much of my stock solution. So I only make what I need. So I'm making 550 milliliters. That's the amount that I'm going to need for this particular reaction that I'm doing. Okay, so we're going to use M1 times V1 equals M2 times V2. What do we know? Well, we know the concentration of the stock solution, the concentrated solution, is 12.0 molar. That's M1. We don't know how much of that we're going to use, so we don't know V1. We do know the concentration of the dilute solution, what we want it to be, 1.050 molar, and we know that we want 550 milliliters of that. So we're going to solve for V1. That is, we're going to set it up and solve for V1. So I like to do my algebra first. M1 times V1 equals M2 times V2. Solving for V1, you get M2 times V2 over M1. The nice thing about this formula is you don't have to put your volume in liters because whatever unit your volume is the unit that'll come out on the end there. So M2 and V2 are 1.050 molar and 550.0 milliliters, and M1 is 12.0 molar. Molar cancels, the capital M's cancel, and you're left with just milliliters, 48.1 milliliters. That means I need 48.1 milliliters of my stock solution, and then I add enough water to reach a total volume of 550 milliliters. So 500.19 milliliters will get me there. Okay? And that's all there is to dilutions. And actually, the dilution formula is much more commonly used when making solutions. I do it all the time. At least once a week, I'm making a solution from a stock solution, and I'm just diluting it instead of making up a fresh solution. Usually you can go into a stock room and you can find concentrated solutions of things that you want to make. And so instead of actually having to take the time to measure out the mass of the stuff and then wait for it to dissolve, some things take a while, I could just take a solution that somebody else made and whose concentration I know, if the concentration is greater than the one I'm trying to make, and I can just dilute it to whatever I need. And I just use M1V1 times M2V2 equals M2V2, and I solve for whatever it is I need. Very simple to do and very common.